reversible. So first thing we'll do is like the definition of reversible reaction itself. Now, reversible reaction is the one which can proceed in both directions, forward and backward, right? तो इसकी definition पहले लिख लेते हैं. It's like a reaction that proceeds in both directions. That is forward and backward. Such reactions are called reversible reactions. Just ionization, हाँ, good shabash. Any reaction in which you put this 2 arrow, that means that's reversible, right? Before I give you an example, let's define another thing here, which comes in definition part. And that is equilibrium, right? Equilibrium. इसी के साथ next लिख. Equilibrium. अच्छा, अब equilibrium is that state at which the rate of forward reaction is equal to the rate of backward reaction. Let's just write this definition first. It is that stage or state at which the rate of forward reaction is equal to the rate of backward reaction. No. Is equal to the rate of backward reaction. जब आप डेफिनेशन लिखते हैं ना, उसको मैथमेटिकल फॉर्म में नहीं लिख सकते आप. Unless the examiner says के put it in equation this thing, तो फिर आप उसको लिखोगे rate of forward reaction equal to rate of backward, तो वो mathematical form है. Definition has to be in sentence form. Okay, so अब मैं इन दोनों को explain करूंगा with example. You guys need to understand it. It's really important concept, and this is one of those concepts which I see students are not very good at. I mean, the good thing is के और bad thing is कि examiner IGCSE में से बहुत tricky मुश्किल question नहीं पूछ रहा होता. They just ask you one thing all the time: position of equilibrium, left जाएगी, right जाएगी. Even then, students don't write it properly. थोड़ा सा हम इसको will study it in proper way so that this concept is clear in your mind. जब देखें, let's say we have this reaction where this is like the example of both of these things. So if there is this reaction where ammonia reacts with HCl to form ammonium chloride. Ammonia plus HCl forms ammonium chloride, and that this has this 2 half arrow sign in between, ये वाला लगा हुआ है. Up, once you guys write it till here, I'll explain it. I'll mention a few things. There is nothing important to write in that. तो जो बोर्ड पे मैं बाद में लिखूंगा, I'll let you know that you can copy. ठीक है, उससे पहले बस आपने इसको समझना है. What is this thing, by the way? अब देखें बोर्ड पे जरा, everyone. First thing, not every reaction is reversible. ठीक है? Most of the reactions are rather irreversible. आप देखो इससे पहले all the equations that I've written, I've put this one direction arrow between the reactants and products, right? Except for very few, maybe ionization में कहीं मैंने लगा दिया हो ये वाला, but I've been writing this. That means, in fact, most of the reactions otherwise irreversible. That's irreversible. This is reversible. So very few reactions are reversible, first thing. But if a reaction is reversible, you need to understand that the chemistry of such a reaction which is reversible is slightly different from a normal reaction. Okay? First thing, when you see this sign in a reaction, you say it's a reversible reaction. Okay? and a reversible reaction is the one in which can go both in forward direction and backward direction also. दोनों साइडों पे जा सकता है. What does that mean? It means that when, let's say, I start my reaction, so I start my reaction with the reactants only. इनसे start करूँगा. I'll have ammonia with me, NH3. I'll have HCl with me. I'll just put them together. That's the start of the reaction. That is only forward. So when we start our reaction, we only have the forward reaction going on. सिर्फ forward जा रहा होता है, right? And then what happens is, after some time, we have enough amount of product. That product starts to break down itself. ये वापस reactant में break होना शुरू हो जाएगा. So the time when the reactants, the product break back, we say that the reversible reaction has started. So initially it was only the forward reaction, like ammonia plus HCl were combining to make ammonium chloride. But once the ammonium chloride concentration was enough, that backward reaction starts. अच्छा, अब जब backward reaction start हो जाएगा, after that what will happen? That the rate of forward reaction will be equal to the rate of backward reaction, right? What does that mean? इसका मतलब क्या होगा? And that is what we call equilibrium. Equilibrium in terms of the rate. So equilibrium means that the amount of ammonium chloride being formed after equilibrium, the amount of ammonium chloride being formed is equal to the amount of ammonium chloride that is breaking back. ठीक है, जितना बन रहा प्रोडक्ट उतना ही वापस ब्रेक हो जाएगा. So once that starts happening, we say that the reaction is at equilibrium now, meaning that the product concentration and the reactant concentration becomes constant. It doesn't become equal. Many students take equilibrium in sense of equality, equal concentration. No, equilibrium does not mean equal concentration. Equilibrium mean maybe equal, maybe different concentration, but whatever the concentration, they become constant. वो change नहीं होती फिर, ठीक है? They don't change after that. Why don't they change? Because जितने molecule product के बन रहे हैं, उतने ही molecule break down हो जाते हैं, ठीक है? After equilibrium, if 10 molecules of ammonium chloride are formed, so 10 will break down. So the number of molecules of product and reactant will become constant, right? That is what equilibrium means. And why does it happen? Because the rate at which the forward reaction is happening equals to the rate of backward reaction. जितने product molecules बन रहे हैं, उतने वापस break down हो जाते हैं. That is what we say the reaction is now at equilibrium, right? And the interesting and the funny thing is, the science or chemistry says that if a reaction reaches equilibrium, okay, if a reaction reaches equilibrium, then it can actually maintain its equilibrium forever if we don't disturb it from outside. Okay, that's a principle. We call it Le Chatelier's principle. मैं लिख भी दूंगा इसकी definition भी आपके syllabus में. So Le Chatelier was the scientist who gave this principle or law. Okay, if a reaction is reversible and it reaches equilibrium, then it will stay at equilibrium forever unless disturbed from outside. How would you disturb a reaction? You could actually change the concentrations. You put more reactant inside, then equilibrium will be disturbed. Or you could actually change the temperature of the reaction, heat it more or heat it less. That is what you're causing disturbance. फिर equilibrium disturb होगा. Or if it has gases in it, so you could actually change the pressure. तो भी equilibrium disturb होगा, right? So a reversible reaction gets disturbed by external changes, but then again it tries to maintain its equilibrium. फिर वापस अपना equilibrium लेके आ जाता है, ठीक है? So Le Chatelier principle, I write it down, is that a reversible reaction maintains its equilibrium no matter what. इस तरह से वो मैं आगे लिख दूंगा. और वही हमने पढ़ना है कि if a reaction is reversible and we change temperature, then where does equilibrium go, left or right? और concentration नहीं जाएगा ना, equilibrium shift करेगा, फिर वापस equilibrium पे आ जाएगा. Position of equilibrium will shift. तो हमने वो बताना है कि किधर shift होती है. And eventually we know it will come to a new equilibrium. There are some changes in which there is no position shift or equilibrium shift, like in most of the time the position of equilibrium shift, and that is what comes in paper. ठीक है, अब आपको, I hope you understand that one. You see these two half arrows in a reaction, we call this reaction a reversible reaction. And what does that mean? The products are not very stable and they can break down into reactant on their own. And then equilibrium means that the rate of forward reaction would equal to the rate of backward reaction, right? अब among all this description that I've given you, इसमें एक दो points important है. I'll write them down and then go to the factors which disturb the equilibrium of reaction. ठीक है? So if you'll have any question in your mind in between, it's a very conceptual thing you can ask, but normally the question would come when we discuss the factors, right? तो अब इसके साथ आप लिख लें कि initially, I mean, in a reaction, initially only forward reaction takes place. Only forward reaction आ जाए साथ. When the reversible reaction starts, initially only forward reaction takes place. After some time, backward reaction starts. And then finally, equilibrium is reached. Finally, equilibrium is reached. That is when the rate of forward backward reaction is equal. See, this is what you write if you're asked to describe a reversible reaction. Okay, what happens? नहीं points में नहीं लिखना मड़ा. Sentence में paragraph में लिखना ये मैंने हमेशा कहा है. ठीक है, ये points तो मैं इसलिए I'm just writing these points so that you remember the 3 points to be there in your answer. Don't write them in points in exam. हैं? हाँ क्यों नहीं, मैं बताता हूँ. अच्छी बात पूछी आपने. The thing is that the way you study languages or literature, for example, of English literature में you get to describe something or write an essay on something. You write all that in points. ये scientific comprehension नहीं पढ़ा कभी? Comprehension पढ़ा है ना concept. एक चीज होती है जो नहीं बैठे रहो इधर. तुम्हें मेरी क्लास में वॉशरूम याद आ जाए तो सारी रिकॉर्डिंग हो जाएगी अभी. तुम बैठे हुए जब मैं आया था तो उस टाइम फ्री बैठे थे, तो पहले वॉशरूम जाओ. हर केमिस्ट्री की क्लास में वॉशरूम जाने का क्या मकसद है? हाँ, तुम अपना बायो क्लॉक स्विच करो. अभी मैंने आज मना किया ना, क्लॉक बंद हो जाएगी, डोंट वरी. अब देखो सारी रिकॉर्डिंग होगी, पता नहीं किस किस स्कूल में जाएगी. अभी मैं नाम बता दूं, आई एम टॉकिंग टू मोहम्मद अली राना. चलो अब पढ़ा लेने. So scientific comprehension में examiner wants you to be able to write your concept in a connected paragraph, and that makes science. तुम जाके कैम्ब्रिज वालों से लड़ लेना ना, या यूनिवर्सिटी वालों से लड़ लेना एक ही दफा. जो चीज आप लोगों को बताई जाती है उसको फॉलो करो. यही मसला तुम्हारा है, तो तुम बुरे तरीके से फेल हो रहे सारे टेस्टों में. अभी मैं बात कर रहा हूँ मिस्टर हमजा से. ठीक है, हम हमजा खान, इस तरह का एक ही होगा. अच्छा, अब इसके बाद लिखो आगे. I wish Mr. Umar was able to understand my golden jokes. He would have enjoyed more. अच्छा, इसके बाद लिखो at equilibrium. Once the reaction is at equilibrium, the concentration of reactants and products becomes constant. That is the first point. And second point is, again, at equilibrium, the concentration of reactants and products may or may not be equal. जाओ. राणा साहब जाओ वॉशरूम चले जाओ, जाओ चलो, ऐसे मजाक कर रहे थे, अच्छा चलो। So equilibrium means these two things. One, that the concentrations of the reactants and product become constant. It doesn't mean they become equal. That's why I've written that point later. That the concentration of reactants and products may or may not be equal. In fact, may wala point is very rare. The concentration equal bhi ho jaye, equilibrium pe. Most of the time they're different. Up to express this thing with the graph, इसके नीचे आप एक इसी रिएक्शन का अलग से हम एक ग्राफ बना सकते हैं। Now, for any reversible reaction, one of these graphs can be correct. ठीक है? Three graphs. Y-axis पे concentration in short we write CONC and its time here. Concentration and time. So for a reversible reaction, one of these three graphs can be correct only. Okay, so we'll label these graphs as graph A, B, and C. These are the graph for a reversible reaction. For any random reversible reaction, one of these graphs will be correct. आप लोग पहले इनको बना लो, फिर मैं इनको एक्सप्लेन करता हूँ. Done. जल्दी करो. हमजा मोबाइल यूज मत करो. कोई बात नहीं, नहीं रेज नहीं करना. आप ग्राफ बनाओ तीसरा, उसको ले टैग चेंज कर दो, क्या फर्क पड़ता. अच्छा, आप देखें जरा बोर्ड पे देखो ना. 1 No one to write anything after this now. पहले समझें and then you copy it. Each graph has two lines, right? Two curves. One of the line is for the reactant concentration with time, and the other is for the product concentration with time. ठीक है? सारे ग्राफ्स में क्वेश्चन ध्यान से सुनना, अली इधर ध्यान. सारे ग्राफ्स में one line represents the concentration of reactants, the other is for the product concentration. Now you guys tell me that in this graph A, which line represents reactant concentration? अब मोमिन बताएगा the answer is correct. Why this line is for reactant? उसने कहा ऊपर वाली लाइन रिएक्टेंट की है, मैं ये कह रहा हूँ इसको एक्सप्लेन करो. Why that is correct answer. Why is this line for reactant concentration? मुझे नहीं पता, मैं तो फ्रेंच लैंग्वेज पढ़ रहा हूँ. एक सेकंड, अभी देखना ये आंसर देगा. या बंदा पकड़ो, मैं बता जिससे पूछूं, किससे पूछूं बताओ. उमर से नहीं पूछूंगा, अली से. हाँ, this line is for reactant. नहीं कांस्टेंट होती है बेटा. Why is this line for the reactant concentration? बताओ. टाइम के साथ this line shows decreasing concentration. तो टाइम के साथ किसकी कंसंट्रेशन डिक्रीज होगी, रिएक्टेंट और प्रोडक्ट? रिएक्टेंट की कंसंट्रेशन टाइम के साथ डिक्रीज होती है ना, प्रोडक्ट तो इंक्रीज होता है. उसको समझ आ गई, आपको समझ आई? हाँ, अभी देखो, when you start your reaction, you start with reactants or you start with products. So when the time progresses, the concentration of reactant will decrease or increase, or product increase. समझ आई? इसको याद रखना बेटा, फिर पूछ लूंगा मैं, क्योंकि मुझे पता चलता है किसको समझ आई किसको नहीं. So each graph, decreasing line is for the reactant concentration and increasing is for the product concentration. All right. So अब decreasing concentration को मैं R से लेबल कर रहा हूँ, इधर बोर्ड पे देखो. Decreasing for reactant, R for reactant, increasing product P. Okay. Nothing. अब in graph C, which line is for reactant concentration? Go again. अभी कहते समझ आ गई. इनमें से कौन सी वाली लाइन रिएक्टेंट की है, this or this? The lower one. ठीक है ना? Good, शाबाश. That's what I wanted to make sure. So decreasing reactant, increasing product again. So we label it as R and P again. And this graph, both concentrations are equal at the end. R for reactant, P for product. इसके साथ आप लिख लो. R यहाँ पर ग्राफ पे रिएक्टेंट्स को दिखा रहा है और P प्रोडक्ट्स को. Alright. अच्छा, अब before I move further, Mr. Umar, you're asking a question.
So what is the reactant concentration? It starts very high, and the product is very low. The concentration.
Good question. Same thing that I asked Momin. When you start a reaction, will you start with reactants or products? Reactants. So I could have very high concentration of reactant. I could start here. I could start here. But I won't start here with the reactant concentration. That is 0 here, right? And at time 0, when the reaction has not started yet, the product is 0, right? So the product concentration in every graph will start from origin. So that's why it's low, and product reactant I can start anywhere I want. अच्छा, अब मुझे आप लोग बताओ, सोच के बताना है, सबके लिए क्वेश्चन. On each graph, when the concentration is getting leveled, straight हो रहा है लाइन जहाँ पर, let's say इधर यहाँ पर हो रहा है, इधर इस जगह हो रहा है और इधर ये हो रहा है. पहले मेरा क्वेश्चन सुनो. आप दोनों को ना मैं इतनी डांट पिलाऊंगा कि सीधे हो जाओगे. रिकॉर्डिंग हो रही है. मेरे पास 2 बच्चे आते हैं ना, जितना पहले आप दोनों आए, अब तक वो एग्जाम दे चुके होते हैं. आप लोगों के सस्ते जोक से नहीं खत्म हो रहे. इधर बोर्ड पे देख के समझो. नहीं, पहले क्वेश्चन तो समझो ना. बनाने की लाइन बनाने में कितनी टेंशन है, उसकी टेंशन पड़ गई बनाने की नहीं. अब सुनो, ये जो मैंने लेवल कर दिया जहां पर जिधर ब्लू लाइन मार्क की है, व्हाट डज दिस पॉइंट रेफर्स टू? लाइव आप नहीं बताओगे बेटा, ये जो जिधर मैंने लाइन ड्रॉ कर दी है एक एक ब्लू, व्हाट डज दिस रिफ्लेक्ट? मुझे पता तुम्हें आंसर आ गया, 7 बताएगा बेटा, ये किस चीज को रिफ्लेक्ट करिए लाइन? गुड, शाबाश, गुड। हाँ, end of reaction, yes, but in terms of reversible reaction we use a specific word for it. Go ahead. Equilibrium, yes. The leveling of the concentration of reactants and product, जैसे मैंने इधर किया लेवल, इसको इधर मार्क किया है, this represents equilibrium. Alright, तो अब आप ये लाइन ड्रॉ करके सारे ग्राफ्स पे, तो किसी एक पे लेबल कर दो इक्विलिब्रियम। अब इस पे एग्जामिनर आपसे क्वेश्चन जिस तरह से पूछता है ना, मैं वो भी बता देता हूँ। इनफैक्ट दिस ग्राफ सी दैट यू सी, इसमें एग्जामिनर आपसे क्या करता है कि मार्क कर देता है पॉइंट्स। लुक एट द बोर्ड अली, एक ये पॉइंट मार्क करेगा, इसको चेंज नहीं करना आपने खुद से। दिस पॉइंट, दिस पॉइंट, दिस एंड दिस पॉइंट, दे लेबल देम एज A, B, C, D. MCQ's question, and it says this graph is for a reversible reaction. Which of the latter A, B, C, D reflects equilibrium? ये बहुत से बच्चे इसको A को बताते हैं, which is wrong. जहां पर लाइन इंटरसेक्ट कर रही है, that's not even equilibrium, right? We don't teach you. That point is perhaps that very brief time when the concentrations were equal. ठीक है, बट उसके बाद भी देखो तो ये चेंज हो रही है, यहाँ कांस्टेंट हुई है। अब the equilibrium is that time when the reaction the concentrations have become constant, right? उसके बाद इधर भी कांस्टेंट है, इधर भी कांस्टेंट है, but we take that time when it just became constant, right? ये चीज याद रखनी है आपने, ये एमसीक्यूज में ऐसे ग्राफ आते हैं। अच्छा, अब लास्ट क्वेश्चन, that is reactant product. Okay, I said the reactant and product concentration at equilibrium become constant. अब देखो constant हो गई। Two questions actually, not last. Why in these graphs reactant concentration is not touching zero? देखो कोई reaction होगा, एक second, good. When a reaction takes place, the reactants get consumed out, right? So their concentration decreases. So in a typical irreversible reaction, the reactant becomes zero. But none of these graphs show reactants touching x-axis. Why? Because it's a reversible reaction. In reversible reaction, products keep breaking back to reactant, and we can never have reactant concentration going down to zero, right? So ये zero पे कभी नहीं जाएगा। अब last question. I wrote the concentration of reactants and products at equilibrium may or may not be equal. ठीक है, कांस्टेंट तो सब में है, कांस्टेंट होगी ना, इधर भी कांस्टेंट होगी, इधर भी, इधर भी, इधर भी, बट आई सेड इट मे और मे नॉट बी इक्वल। अब आप लोग मुझे बताओ which graph represents may be equal? बड़े चार्ज हुए वो, गुड। So may be equal is this, at equilibrium the concentration of reactant and product is at equal level, right? So this graph B shows reactant equal to product. अब इसी चीज को माइंड में रख के बताओ इसके साथ में क्या लिखूं? At equilibrium reactant concentration is more than product, right? So it's very much possible, नहीं माइनस नहीं करना, reactant greater than product, and this one is where reactant concentration is or reactant lesser than product. You could be asked this in MCQs even, like which of the following graph shows that at equilibrium reactant concentration is equal to product or lesser than reactant or all. I'll draw a fourth graph and someone will have a heart attack, I know. That will be a wrong graph, and you guys need to tell me why is that wrong. So one of these graph can be correct for a reversible reaction. ठीक है, all these are 3 correct graph. अच्छा, अब by looking at a reaction we can't tell कि which graph will be followed, right? Unless we are told the concentration. अगर मैं आपको ऐसी values दे दूं, reactant concentration is equal to product data 0.5 0.5, so you could actually tell me which graph would it follow, right? जब equal given होगी B, अगर मैं product ज्यादा दे दूं ये, ठीक है. अब it's not very strange कि जी equilibrium भी आ जाए and reactant are still higher than product. It's very much possible. ऐसा हो सकता है. But this won't happen. Like this graph, it's like MCQs में ये चीजें आती. Now this graph I'll mark it as D. इसमें y-axis वही concentration, x-axis पे time. I already said it's a wrong graph. Tell me what's wrong in it. Good year. लगता है chemistry बिरयानी खा गया है. In this graph, I've shown increasing concentration of reactant with time and decreasing concentration of product with time, right? So this is a wrong graph. For any reversible reaction, it's wrong. Without any data given in the question, I can say it's not a correct graph. तो इसको आप अगर draw करो, साथ cross कर दें and write के it shows reactants increasing with time. This graph shows reactant concentration increasing with time, which is not possible. Obviously, reactant concentration will decrease with time. अब कल मैं आप लोगों को पढ़ाऊंगा the factors which affect the position of equilibrium. But right now I'm gonna distribute your test back. क्या हुआ? हाँ, दोनों ही चेक किए हैं मैंने. 8 10 है यार. हाँ, वो आपने देना, ये तो मैं आपसे कह रहा हूँ, मुझे याद है किसने कौन सा नहीं दिया. जिसके टेस्ट के मार्क्स कम है, जिसने टेस्ट मिस किया हुआ है, उसको टेस्ट देना होगा वापस थर्सडे वाले दिन ही. ठीक है, छुट्टी नहीं है, छोड़ूंगा नहीं मैं. अच्छा अरीबा, पहली बात बेटा, यू आर लेट इन क्लास, टाइम पे आना है. दूसरी बात, आप चेक योर टेस्ट सर, कामरान विल सेंड यू द व्हाट्सएप कॉपीज ऑफ दिस. ठीक है, मार्क्स नहीं बताऊंगा सबके सामने, फिर आप कहोगे बता देंगे. आमना इज नॉट इन द क्लास. बताऊं ऊपर एलिजे के टेस्ट, ये लास्ट टेस्ट है बेटा जिसमें मार्क्स अनाउंस नहीं कर रहा. इसके बाद सारे टेस्ट में मार्क्स अनाउंस होंगे और ये ऐसे रिकॉर्डिंग में दिखा के आगे जाऊंगा ताकि रिकॉर्डिंग में भी सेव हो जाए. साथ बेटा आप टाइम पे आओ, ठीक है ना. डू समथिंग बट कम 10 मिनट्स अर्लियर. मोमिन, ये आप लोगों का एसिड बेस वाला टेस्ट. हमजा फार्म, कासिम, थोड़ी मेहनत करो. ये गपस्तान रेडियो को छोड़ के ना थोड़ा, अरे यार रिकॉर्डिंग तो बंद करो. ऑनलाइन वाले बेटा आप लोग, यू कैन नाउ इवन लीव बिकॉज योर मार्क्स आर विद मी. सर कामरान विल शेयर द टेक्स्ट एंड एवरीथिंग.